Good afternoon, and welcome to the 8th webinar of the ASEAN Center for Energy. In today's webinar, we will discuss the small-scale liquid natural gas or LNG role in ASEAN's interconnection. First, let me introduce myself. My name is Sania, the Technical Officer for the ASEAN Plan of Action for Energy Cooperation, or the APAEC program, and I will be the moderator for our webinar today. Before we start the webinar, let us give you a brief introduction of ACE. The ASEAN Center for Energy, or ACE, is an independent intergovernmental organization within the Association of Southeast Asia Nations, or ASEAN structure, that represents the 10 ASEAN member states, or AMS, interests in the energy sector. ACE has three critical roles in the ASEAN's energy sector. First, think tank, to identify and surface innovative solutions. Second, energy data and knowledge hub, to provide a knowledge depository for the ASEAN member state. And last, catalyst, to unite and strengthen the ASEAN energy cooperation and integration. This webinar is also a teaser of the ASEAN Energy Business Forum, the only business forum where energy policymakers of all 10 ASEAN member states will be gathered and connected. The IEBF is organized by ACE and consists of three elements: conference sessions, ASEAN Energy Awards Night or Gala Dinner, and exhibition or business-related activities. The event will be held at SENS Expo and Convention Center in Singapore on the 20th to 30th October 2018 with the theme Interconnecting Energy for an Integrated and Competitive ASEAN. Session 2 of the IEBF conference will discuss the relation of the Trans-ASEAN Gas Pipeline, or TAGP, with the LNG industry, which is related to today's webinar, Small-Scale LNG Role in ASEAN's Interconnection. So let us invite two speakers and a panelist. The first speaker is Mr. Tony Regan, the Managing Director of Delta Fusion. Second speaker, Dr. Yan Pei Lee, Energy Economist, Economic Research Institute for ASEAN and East Asia, or AREA. And one panelist, Professor Haslenda Hashim, Deputy Director of the Process Systems Engineering Center and Head of the Green Energy and Environmental Planning Research Group at the School of Chemical and Energy Engineering, Faculty of Engineering, University Technology, Malaysia. Each speaker will be given 15 minutes of presentation, followed by discussion and questions that will be chaired by the panelists for 20 minutes. If you, as the audience, have any questions during the webinar, please type them into the question box in your GoToWebinar control panel. Okay, let us begin the first presentation of the potential of small-scale LNG system in ASEAN by Mr. Tony Regan. Mr. Regan is a Singapore-based oil and gas consultant with extensive international oil and gas experience. His expertise is gained during the 25 years with Shell International and more recently with S&P Global, Platts, and with Trizon International and Nexen. Mr. Regan is a gas and LNG specialist focusing on global LNG and ASEAN natural gas markets. Mr. Regan, can you hear me?
Yes, good afternoon.
Yes, good afternoon. Kindly please proceed with the presentation. Okay.
Right, well, first of all, what is LNG? And that's very simply natural gas that's been frozen to by 160 degrees Celsius, and that reduces it in size 600 times. So you then have something that's much easier to transport than pipeline natural gas. And nowadays we're talking about conventional LNG, small-scale LNG. What is conventional LNG? Well, it's large liquefaction plants, which could be 5 million tons. It's large terminals, which could be 3 to 5 million tons per annum of capacity. It's large LNG carriers between 150,000 and 260,000 of storage capacity. Then small scale, right? It's small liquefaction plants, it's small LNG carriers, it's small terminals, smaller independent tanks, as well as trucks, ISO containers, rail tank cars, so very small. The next slide will show you the flowchart for LNG. So on the left there, we've got the liquefaction plants, production facilities. We've now got 100 plus very small scale liquefaction plants. Most of those are in China. And then around the rest of the world, we've got the large plants, 34 large plants. In total, we've got about 400 million tons of liquefaction capacity. We've then got a lot of LNG carriers moving this LNG from the source to the destination. And the destination usually requires a terminal to receive the LNG. And we've got about 25 floating terminals, about 100 onshore terminals. We've got about 840 million tons of terminal capacity, so about twice supply capacity. We've got 3 main markets for LNG, the power sector, industry, and then domestic. But an emerging market now is LNG as a fuel. So that's LNG as a marine fuel. It's LNG to fuel trucks. And it's the emergence of this market that is also resulting in a call for small-scale applications. In addition, we're seeing a lot of interest in LNG to power. Some of these power plants are very small, or they're located where there's very shallow draft. And so you can only use very small LNG carriers, and the parcels required by these power plants are relatively small. So the power plants, the small-scale power is also stimulating a demand for small-scale LNG. And the next slide, Norway has traditionally been used as a country where you can illustrate the application of small-scale LNG. They've got a large-scale LNG liquefaction plant, they've got large-scale LNG terminals, but they've also got 28 small LNG terminals. Even in some places, very small independent storage. They've got some feeder vessels, which are between about 7,500 and 20,000 cubic meter capacity, and then some very small LNG carriers, about 1,000 to 10,000 cubic meter capacity. They use trucks, they use rail tank cars and pipelines, and they've also got 7 LNG bunker terminals. All that supplying the traditional customers, industry, power, trucking companies, ferries for the bunkers, and offshore service vessels are also taking bunkering. So that's Norway, which is seen as a classic picture of small-scale LNG. What do we mean by small, big scale? Here we've got a liquefaction plant. This is Rasgas in Qatar. 7 liquefaction trains, total capacity 32 million tons per annum of liquefaction capacity. But mini would be 20 to 100 tons a day of liquefaction capacity, and the picture below shows a plant producing 10 tons a day. Small, 10 to 500 tons a day, and a mid-size would be 500 to 300 tons a day. What do we mean by small-scale terminals? Well, on the left there's the Singapore terminal, a large LNG terminal, capacity of 11 million tons per annum. Bottom right, we've got an Innoshem in Sweden, 0.25 million tons per annum. And in fact, we then get down to ultra small, 30 to 70,000 cubes of storage. And that could be the tanks to support a filling station. Small scale, say 10,000 cubes of storage. Mid scale, 50,000 cubes of storage. And so how is this, are these small scale markets emerging globally? It varies. In North America, the driver is very much to provide LNG as a bunker fuel. And that's the same in Europe. But also in Europe, we're seeing a lot of interest in LNG as a truck fuel. So that's also driving the emergence of small scale applications. In the Caribbean, it's LNG to small scale power being supplied with small parcels of LNG from the US. In Asia, China is the big market for small scale LNG, but the drivers there are trucked LNG. So that's actually carrying LNG in trucks to deliver it to industrial customers, or LNG as a truck fuel. There's a little bit of interest in LNG as a bunker fuel that's growing. In Southeast Asia, the focus is much more on LNG to small scale power. So, the small scale applications interests vary significantly from region to region. It's a flow chart. And it's more complex than large-scale LNG. The top line, that for instance shows a gas going into an energy filling station. So we start with possibly small-scale liquefaction. The LNG is then trucked or carried in an ISO container to intermediary storage, and then maybe trucked to the service station and supplied to trucks. Elsewhere, slightly more conventional. The LNG is coming from a traditional liquefaction plant or exoterminal, carried in a small-scale LNG carrier, and that delivers it into possibly a small floating storage unit, floating regas unit, a small FSRU, floating storage and regas unit, or a small onshore receiving terminal. From those facilities, it then goes by truck, barge, pipeline to the end users, industry, power, mining, and ships. And now China, that is now emerging as a significant small-scale LNG market. China's got 20 large-scale receiving terminals, but it's also got 4 small-scale LNG receiving terminals. It's got over 100 small-scale liquefaction plants, over 5 million natural gas-fueled vehicles, and 250,000 of those are trucks. To support those, over 3,000 LNG service stations, and then there are over 10,000 trucks carrying LNG to the end users. They're beginning to show an interest in LNG as a bunker fuel, and the focus is on the inland rivers. And we've now got about 106 vessels plying the inland rivers that are supplied by LNG bunkers. In Asia, we've got the first small-scale receiving terminal, a floating terminal, and it's a combination of a very small-scale floating storage unit, which you see there on the left, and coupled with a floating regasification unit. Both have a capacity of about 500,000 tons per annum. And we can vary this. You may have some floating storage, but you could put the regas onshore. And then we're also seeing people consider small-scale floating storage and regasification units. And those are scaled-down versions of the big ones we see in service around the world. Now, a significant issue with small-scale LNG. Small-scale can be relatively expensive. Here is an example of a small-scale LNG carrier. Now, a conventional large-scale LNG carrier will cost about $210 million. Mid-scale, about $105 million. A small-scale one, about $50 million. So relatively expensive. So there, it's a quarter of the price of the large one, but only carries less than 10% of the large one. And this is an issue with other aspects of small-scale applications. Terminals also are relatively expensive. The cost doesn't scale down commensurate with size, unfortunately. and this has become a key issue, the development of small-scale applications. But that's not the only challenge. There are a number of challenges here. Lack of experience amongst the governments, the regulators, the project sponsors. They're new to LNG in many cases, and so it takes time to get their heads around the idea of using LNG, and then if necessary regulating it, or even having to pass legislation. The project sponsors, they may have sponsored a power project in the past, but probably an oil-fired one, coal-fired one, first time they've used LNG. So, you know, a lack of experience, lack of knowledge. There's also a lack of the environmental and commercial drivers in Asia that we see in Europe and North America. The main environmental driver in those areas is the push to get down to ultra low sulfur fuel for marine fuel, 0.1%. We don't have the same driver in Asia. And the commercial drivers are also a little bit weaker. Sometimes markets are subsidized, so we don't have the same competitive pressures that we do in some of the Western markets. Another issue is what I call a lack of consistency in energy policy. It's a bit of a flip-flop of energy policy that governments suddenly decide they've gone off nuclear, or they're suddenly going pro-nuclear, gone off coal, or suddenly pro-coal. Want to decarbonize? No, we'll continue to use oil and gas. Want to use more renewables? Fine, but what does that mean to gas requirements? So the lack of consistency in energy policy is also causing issues. We don't know what the future demand is going to be for this LNG we're considering importing, which clicks down to the next point, the uncertainty about the demand. Because of these changes in policy, is that power plant that was supplying the LNG going to continue to be used as base load and require quite a lot of gas, or switch to peak shaver and require much less gas? And then we've got some poorly infrastructure design projects. Because of the lack of experience, the project developers come in with oversized storage, expensive marine infrastructure. They go to locations where they're going to need big breakwaters, a lot of dredging. That's very expensive. There's also a degree of protectionism, and you know, we've found examples of where there's been resistance to the introduction of LNG because it may be backing out diesel, so the supply of the diesel is not going to support a new LNG project. Nature, that's quite a significant challenge. I mentioned earlier that shallow water, restricted draft, it means you can't get conventional LNG carriers to some markets. Typhoons, monsoons are a big issue in Asia, which can result in a lot of debris flowing down in rivers. You've got the vessel may have to go up a river to get to its client, but with all that debris in the river, those vessels struggle because their propulsion systems are not protected against that sort of debris. So it's perhaps inappropriate vessels being used that are an issue. And then the other challenge is the high costs, and that's really because every part of this chain has not been properly optimized to ensure you do have cost-effective, economically viable solutions. How do we get to fit-for-purpose solutions? You know, LNG carriers, the terminals, jetties, breakwaters, all expensive. Do you need them to meet this requirement? Do you need an LNG vessel? Could you do with a coaster with a C-type tank on it, or even barges, ISO containers on container vessels? Jetties, breakwaters, do you need them? Can you, for instance, use the port facilities nearby rather than building new facilities? Go to somewhere in shallow water or sheltered water where you don't need the breakwaters. Look at the possibility of using trucks and ISO containers for the very small markets. Possibly cut out that onshore terminal. use an FSU or an FSU as a mother vessel, as a floating terminal, and feeding small barges, small vessels that go to the end user. Think about a joint replenishment program. Don't design these facilities just to support one client. Look to see where you can supply perhaps 3 power plants. Look at other markets. Can you use this facility to support the supply of, say, LNG to industrial users in the region, or LNG as road fuel? So, look to see whether you can develop new markets close to these terminals. And this all improves the economics of these facilities. Look at a completely different concept when it comes to shipping and terminal. Here we've got a very small floating terminal, containers for storage. A large terminal, a large FSRU may require 20 to 30 staff. This one, 2 staff. They go home at night. And so, a very simple, very cost-effective solution. It's got its own power supply, so it's completely independent. The delivery to the end users. So instead of the small LNG carrier, then perhaps barges with both storage tanks, so you can discharge from those tanks, but also those ISO containers, so discharge ISO containers to the end user. Pick the ISO containers up when they're empty and put them back on this barge, refill them on the spot from those tanks. And so, we have different approaches to the terminals, to the supply. And I can't stress enough the need to optimize and enhance, because a lot of projects, particularly in this region, are not coming together as quickly as people expected, and that is because we haven't spent enough time really optimizing and enhancing the opportunity. And what we also need is a stronger message, a vision, and that we're also seeking to promote LNG as a diesel replacement. If you talk like that, then there's some logic in saying, yes, we need more LNG to industry, LNG as a road fuel. And that's going to create new markets in the destinations for these small-scale applications. Means they'll be able to absorb more LNG, market more LNG, and that will bring down the unit cost of the facilities. This is a very complicated slide. The slide pack will be available to you afterwards. But the message here is, the top line is, let's call it conventional energy cost base, and then we've got small and very small below. The message here is, if you really look very closely at those small scale projects, really optimize them, have fit for purpose technology, then you can get your cost down comparable to large scale. So it's not impossible, but it is a huge challenge, and not many people have managed to meet that yet. And that's another reason why a lot of these small-scale projects are not yet being sanctioned, because the developers have not yet found a way of getting their costs down to the sort of level that we're indicating could be possible here. So, sum up, ASEAN opportunities, there are a lot. Now, it's LNG to power, to small-scale power, particularly in Indonesia, in Myanmar. Our next speaker is going to be talking about the possibilities in the Philippines. Diesel replacement. This is something Korea is very enthusiastic about, getting diesel to offshore islands, to remote off-grid areas. But in this area, there's a lot of focus, particularly in Indonesia here. LNG as a bunker, well, the leader here is Singapore. There's limited interest elsewhere within ASEAN, but not yet significant. It's starting. LNG as a transportation fuel, Thailand, just starting to see some interest in other countries. LNG as a fuel for heavy plant, particularly mining equipment. Indonesia, there's interest from the, say, East Kalimantan miners in using LNG to fuel their plant and their huge trucks. And the markets we should be watching and learning from, China. It's become the biggest small-scale LNG market. And now India, because that's now developing its domestic gas market, it's developing its domestic LNG market, and we're now seeing them introduce some small-scale applications. So, watch how things develop there. Closing slide, just pictorially what we mean by small-scale LNG, the applications. Top right, a very small LNG vessel, and that's also the sort of thing you'll need as an LNG bunker barge. Top there, you've got a truck supplying bunkers to a vessel, so that's very common. You've got ISO containers. We've got LNG filling station with trucks. We've got variations on small storage, vertical, horizontal, and combinations of it. We've got all the technology. We've got more than enough technology. We've just got to be very selective in what we use for our applications. And then we'll see a lot more of these small-scale projects in the ASEAN area going ahead. So I conclude there. And then we'll probably move on to our next speaker, but we'll have a Q&A after that.
Thank you, Mr. Regan, for your presentation on ASEAN small-scale LNG system potential in ASEAN. Now, without further ado, I would like to invite Dr. Yan Pei Lee to present the Philippines small-scale LNG supply chain. Dr. Lee, can you hear me? Hello, Dr. Lee. Please unmute your GoToWebinar. Dr. Lee? So, Dr. Yan Pei Lee is an energy economist of the Economic Research Institute for ASEAN and East Asia or ERIA. He is also a senior scientist adjunct to Energy Research Institute at Nanyang Technological University of Singapore. He specializes in energy markets, energy policy, and economics of technological change. Dr. Lee, please, the time is yours.
Okay.
Okay.
I think finally I'm connected.
Cool.
Can everybody hear me?
Yes, we can hear you well.
Okay, I think I'll just go ahead. There's some lag on the web, but let's try. So I'm an energy economist from ERIA. So from last year, we started this project with the Philippine DOE to look into the potential and also the planning of small-scale LNG to Philippine islands. I will explain to you the reason why we especially focus on the island of Philippines. Can you go to the next slide, please? So the next slide will show you our estimations for the electricity demand from the all the grids in Philippines. As you know, Luzon is a main area where the population and electricity demand is concentrated. However, basically our estimation show that if we build any large-scale LNG terminal for Luzon area, basically due to the high electricity demand and therefore the high demand for LNG as a fuel to power generation, the capacity of the primary terminals built in Luzon area will basically be consumed by the area itself. So there is no remaining or redundant capacity to serve the southern islands of Philippines. Therefore, we are motivated to look into how small to medium size of LNG supply chains can meet the demand of the southern island, especially focusing on the Visayas and the Mindanao areas. Yes, next slide, please. So based on the electricity demand, we estimate the LNG demand accordingly for each region. As I explained, the demand in the Luzon area would be very high. Therefore, it's almost like 9 MTPA per year. So this is usually 3 times the size of one kind of terminal. So we pictured about the 3 primary terminals to be built in the Luzon area. So it's similar to the scale of the LNG facility that has been built in Singapore currently. So for Visayas and Mindanao, you can see the demand in the last column is much smaller in terms of the southern town of LNG compared to Luzon. So it's more suitable for developing small to medium scale infrastructure. Next slide, please. So this one basically explains the situation on the Luzon area. So the plan is probably to build 3 LNG terminals on the Batangas port, Limay port, and Pagbilao port. So basically, each port we consider the build up of 3 million ton per year kind of a capacity in order to meet the demand from this region. And the next slide shows you our sort of high-level vision for Visayas grid and the Mindanao grid. In the Visaya grid, electricity demand is concentrated in the Cebu area, which will consume about 40% of the capacity of LNG infrastructure to be built, so that it has something remaining, some capacity remaining to serve to other ports and islands using the small-scale LNG supply chain. So that means using small to medium size of LNG barges. And for Mindanao, Mindanao's electricity demand is more dispersed. So after considering the ideal locations of the power plants in order to serve where the electricity demand is concentrated, we identified several ports, including Zamboanga, Tagbilaran, Iligan, Bislig, Surigao, and General Santos. So the next slide will show you on the map where these potential secondary or tertiary terminals would be. For example, in the northern part, you see the Cebu port, Tagbilaran, Surigao, and in the southern area, you see the Zamboanga, Iligan, General Santos, and the Bislig. So basically, our job is not only to do the math about how much LNG will be needed and what level of capacity is to be built. Our job is also about how to optimize the infrastructure so that we can minimize the cost. As you know, for this kind of logistic kind of planning, inventory is a main issue. So that means inventory is translated directly into the physical storage capacity that you have to build on each site. So if you build too big a capacity, that might be a waste of money. And if you build too small, uh, there might be sort of a disruption of supply. And in those cases, such as the typhoon seasons, in those cases, there will be kind of a cutoff of this LNG supply and therefore the power generation from the natural gas. So we don't want to invite that kind of a situation, minimize that kind of risk as much as possible while also controlling the cost. So in this case, basically, we will consider two sort of logistics arrangement. One is what we call hub and spoke. That means, for example, you build a larger level of facility in the main port, for example, Cebu, and use that as a starting point to serve the other satellite terminals, which come with certain level of storage. Another one is perhaps in order to save the equipment of the transportation of LNG, as Tony just mentioned earlier, this equipment might be extremely expensive. So in order to save the number of the necessary vessels to carry the LNG, you probably adopt this so-called milk run kind of models. That means you start from some main port and keep it running to the first and second and the third, perhaps a fourth one, until you finish the storage capacity, and then return to the sort of mother port, get reloaded, and start the next journey to feed several others. So compared to the hub and spoke, the benefit of doing so is, of course, capex. But the downside of doing so is possibly the OPEX. As you know, the fuel consumption of running around using the vessels and also making many port calls could be quite costly. Uh, for people who are familiar with marine shipping, you probably know that the call to the ports is actually probably quite expensive. Um, and also, there are many ports here listed here. They come with the limitation of the depth of water at the port. Therefore, large barges to do the milk run may not be able to reach these ports. So these are the cons of the milk run models. So as you see, this is our optimization problem. Please go to the previous slide. Uh, the optimization problem number 2. So these are some verbal description of the optimization problem that we face. So as I tried to explain, firstly, your priority is to ensure that demand at each terminal, satellite terminal, is always met with the capacity of storage that you build and with also the frequency of delivery made by the LNG barges as you planned. This added together could meet the demand. And secondly is the port technical condition. For example, the um, depths of water and so on, the physical conditions. And lastly, we have to consider the cost of terminal, the capex and also operation costs, and also the cost of the LNG transportation. That means the LNG barges. And this cost will add it together as a total system cost. So in our simple linear programming model, our objective will be set as to minimize the total system cost. And the next slide shows you some our assumptions about the capex and opex. Perhaps Tony can help us verify these numbers. You showed the cost for the vessels, but you didn't mention the cost, the capex of the terminals. You didn't mention the OPEX either. Actually, we are not how to say engineering company or industrial players, so we don't have the actual numbers. We take the information from various literature or other sources of information. So these numbers are yet to be verified. So that's why we call them assumptions, the capex and opex assumptions. As you can see, one of the apparent difference between our assumption and Tony's mentioning of the cost of the barges is quite big. So Tony mentioned some 50 million US dollar per small barge, but our assumption is only 3.6 million. So quite a huge difference. Perhaps what he mentioned as the cheaper solutions, which means converting conventional ships and load them with the steel tubes to carry the LNG. So this, if you look at this cost as the conversion cost, I mean the 3.6 million US dollar per ship for conversion and also installation of the tubes, maybe this is still a reasonable assumption. But anyway, because you see the primary terminals and secondary terminals, the terminals are extremely expensive. So compared to the cost of the vessels, I would say that since these are linear models, so if you change the assumption about the capex of the barges, it will not significantly change the sort of optimized planning of these supply chains. So we can change this, we can update these assumptions, but I'm quite sure that the results would be remaining almost the same, except that the total system cost might be much higher because of the assumption about the barges. The next slide shows you the results that the optimized supply chain to serve all these identified demand points. So we simulated many scenarios, choosing different ports as the main port to serve the others, and also choosing between different technologies, for example, onshore terminals or FSRU. So depending on this kind of choices, we have many scenarios. Eventually, we find that the scenario 5 will deliver the lowest total system cost. And in this scenario, basically, Cebu and Zamboanga would be chosen as the primary port built up with FSRU because it's cheaper. And then from these ports, using 3 large barges and 9 small barges, it would be sufficient to serve the remaining 6 tertiary terminals. According to our estimation, this scenario will deliver the lowest total system cost. And just one small note here is that our total system cost in our simple model, this number, 2,000 something million US dollars, it includes the capex of all the terminals and barges, as well as the first year operational cost. The inclusion of the operational cost would help us to better design the system so that it not only minimize the investment, but also the future operational costs, so that we ensure the LNG delivered in the future when the infrastructure is built would come at the lowest costs. So this is our model and our results, main results. And if you want to look into more details, the next slide will show you the delivery schedules of the small barge fleet, and the delivery schedule is made for 52 weeks, which means 1 year basically. So these numbers show you the number of deliveries made uh, to each of the tertiary terminals by small barges, how many deliveries, how many times of deliveries in each week. And the next slide shows you the delivery schedule of the large barges. So due to the higher cost of the large barges, both capex and opex, so as you see, the number of delivery to be made by the large barges is smaller and less frequent compared to the small barge fleet. And our model is also able to consider, if you see the next slide, is able to consider the disruptions caused by natural disasters or other weather conditions. For example, the typhoon. So Philippines is well known as a country frequently exposed to typhoon. So the operation of the supply chain by marine vessels to carry the LNG would probably be interrupted by this typhoon. So this set another challenge to us in designing the supply chain, which is not only optimized in terms of cost, but also optimized in terms of being a robust system against typhoon. That basically set us a new challenge to design the appropriate level of storage to be built on each site, so that with a larger storage on site, the inventory can endure for longer during the typhoon seasons until the next delivery arrives. So we have some detailed result in our report. So if you are interested, you can refer to our written reports. So next slide shows you the where you can get such detailed information. But this report is still under editing, so we will be uploading it to our website as printed here, maybe in about 2 to 3 months. So by then you will be able to access the detailed information from our study. I will stop here and see if any further questions. Thank you very much.
Thank you, Dr. Lee, for sharing with us your study on the Philippines' small-scale LNG supply chain. We begin the discussion and question sessions. We are inviting Professor Haslinda Hashim as the panelist to give her opinion on the experts' presentations. Professor Haslinda, can you hear me?
Hello,
Hello.
can you hear me?
Hi. Yes, I can. I can hear you clear.
All
A
right.
brief
Thank you
introduction,
very much.
Professor. Oh, sorry. A brief introduction, Professor Renda. Professor Renda is one of the ASEAN Science and Technology Fellow from Malaysia. She is also the Deputy Director of the Process System Engineering Center and the Head of Youth Energy and Environmental Planning Research Group at the School of Chemical and Energy Engineering, University Technology Malaysia. Her researches focus on energy and environmental planning, low-carbon society, renewable energy, and resource conservation. Professor Linda, please share with us your opinion regarding the small-scale LNG potential in ASEAN. You have 15 minutes to start. Okay.
Uh, Thank you very much, Tanya, and also to Tony and Dr. Fei. So I think that is a very good presentation, eye-opening in the prospect of small-scale LNG in other countries. So I have a question to um, Dr. Lee regarding the planning, the potential of planning of small-scale LNG in Philippines, because you found that that is a very promising. But for example, in Malaysia, for example, in our country, in the island, um, and also in the remote area, it seems like solar is very promising. So, can you comment in terms of the potential of using small scale LNG as compared to solar energy? Hello, Dr. Lee. Hello.
Thank you. Thank you, Prof. Hashim, for this question. Uh, so, a short answer to this, I think, is that you have two considerations. Firstly, of course, is the system cost, or the levelized cost of electricity from these two potential solutions, from solar PV as against the small-scale LNG. Um, Second one, I think, is the reliability of supply, because solar basically is available only during the daytime. Uh, of course, if you build a large enough solar PV farm, complemented with battery storage, you probably can also power up
Okay,
a
I think that is okay. And then perbaiki again the two sets. Okay,
uh,
then I will do.
so
And then
it probably can still serve during the night,
yeah,
during the
sure.
evening.
Yeah.
So
You
you have
can
two
see
considerations, cost and reliability. So I think these two needs to be balanced. Ideally, I would picture that for island with a relatively not so small kind of a population, you probably can consider hybrid system. That means both solar and LNG, because solar now is getting cheaper and
and then
cheaper,
you give
so
me the two
it
sets.
probably
And then
can deliver
I
cheaper cost, but not so reliable. If you consider battery storage, that would also be make the system cost very high, quite expensive. So may not be competitive as against LNG. So LNG can provide some baseline, and also it's very flexible. So peak supply it can also provide. So LNG, I think, can ensure reliable supply of power. Although the cost may be under current circumstances higher than SPV, but all these are yet to how to say further studied in detail, because every project, the cost would be the cost structure and LCOE would be different. So case by case study, I think, would be necessary. That's my answer. Thank you very much.
Another the second question for you before um I start to ask Tony. So the second question is, if you want to optimize the system cost of small scale LNG, which one you will consider first? Is it the demand side or at the supply side?
Um, so if I understand this question correctly, uh, you are asking if the sound planning on the demand side, for example, the downstream demand from the power plants and also other industrial facilities, could help reduce the cost of infrastructure, the supply side. Uh, I think both sides are actually important in controlling the cost, because if the downstream has a lot of uncertainty, even if the project, the upstream project is started, it will be its financing will be usually more costly compared to the case where there is a certain demand from the downstream. So I think both sides would contribute to minimize the cost. Coordinated planning of both supply side and demand side is the ideal case. So in the Philippine case, I think a unique situation is that they have this so-called liberalized system, liberalized power market, so that the government role is not really strong in coordinating. That is another reason I think this kind of study is very important, so that both the upstream investors and the downstream users they can be coordinated better in better ways. They can be, because they can make better informed decisions. That would be my answer. Thank you very much.
Okay. Thank you very much for your answer. Yeah, because from our research and our reading, it shows that actually we have to consider both, because in terms of demand, actually it could come from the industry, from the power plant, right? So, and if we can cluster the demand side, then we can find what will be the best LNG power plant that can be built in order to minimize the total cost. So yeah, I'm agree with you, Dr. Lee. So now next, I would like to ask Tony regarding the small scale and LNG for transportation, because currently, especially in Malaysia, there are many studies, or even there are pilot tests for compressed natural gas for transportation. So can you comment in terms of the potential of a small scale LNG to compete with compressed natural gas for transportation?
It doesn't really compete, it complements. And so, yeah, where we've got large markets where CNG is used, then it's perfect for cars, taxis, and things like that. Thailand, for instance, it's being used for trucks, but you see these trucks with 6 big cylinders behind the cab. So that's rather overdoing it. You actually need 1 if you are if you're using LNG. And so CNG is fine for the smaller vehicles, cars, taxis, and things like that. But the larger ones, buses and trucks, then it makes much more sense to use LNG. You just need far too much CNG to be viable. And then the urban disposal vehicles and things like that, you tend to use LNG. So it's just CNG is fine for small vehicles, LNG for the larger vehicles and the heavy vehicles.
How about in terms of safety? What do you think is more safe? Is it CNG or LNG?
Probably LNG. The tanks are so strong. And that if a truck overturns, then the last thing that's damaged tends to be the LNG tank. And so also I think the handling, it requires more sensitive handling. It is very cold, so using gloves and things like that. So it'll be handled in perhaps a slightly more professional way than perhaps CNG. So I think LNG tends to be the safer one. CNG is also safe, but LNG is also very safe, primarily because the equipment is so strong and robust.
Okay, all right. So you are also talking about the potential of small scale LNG as a diesel replacement. So can you comment what will be the incentive or anything that can promote this in industry?
Well, the biggest incentive is price. It's the economic driver, and particularly in countries which are using ultra low sulfur diesel. That is a very expensive product. But very simply, LNG is still priced off oil, but it's priced off crude. And so let's say LNG is at crude parity, it's often a discount. But petroleum products are 20, 30% more expensive, particularly diesel. So, diesel will nearly always be more expensive than LNG, even when you factor in the higher delivery costs and infrastructure costs when you're using LNG. And in some cases, those savings can be dramatic. In China, for instance, LNG at the pump can be 50% cheaper than diesel at that same pump. And the target is to ensure it's at least 25% cheaper. But in many cases, it can be 40, 50% cheaper. Diesel, particularly ultra low sulfur diesel, is a very expensive product.
Okay, Professor Linda, you might want to summarize because our time is up.
Oh, okay. Mr. Tony, so can you foresee any other potential of small-scale LNG in the future? Before we wrap up this discussion.
Well, there have been trials using it as an aviation fuel, but I'm not convinced I would be very happy flying on an aircraft that was using LNG. I'd be concerned the tanks would be heavy. No, I think we've got more than enough to focus on at the moment. LNG to small-scale power, and then as a transportation fuel. And the potential of those markets, particularly the transportation fuel market, is huge. And so I think those are the applications we're going to be focusing on over the next 2 years, rather than its use as an aviation fuel. I think the other thing we will probably see is it being used as a fuel for the railways. And so, there are railways using LNG. There are a number of trials. And so we could see train companies using LNG and also carrying LNG in containers on rail tank cars. It's done in Japan quite frequently, and I think we could see that being adopted elsewhere.
Okay, thank you, Mr. Tony. So my last question to Dr. Lee. So if you look at the total supply chain, actually which part actually contribute the highest cost, and how we can reduce the total cost?
Well, thank you, Prof. Hashim, for the question again. If you refer to my slide number 8, there is a table listing the capex of these facilities. I would say the capex and opex of the terminals are the majority part of the costs of the whole system or the whole supply chain. One onshore primary terminal is about 1.2 billion US dollar, and its OPEX calculated by each week is $500,000. So these are extremely expensive facilities from my perspective. So in order to reduce the cost, I would say probably considering like innovative solutions like FSRU. For example, you look at the the fourth row, which is the cost of the FSRU. It's about half. The capex is about half compared to the onshore primary terminals. So making use of latest technologies probably is the most important way to reduce the cost. And other than that, I think it's about optimization and then coordination of the implementation of the whole supply chain from upstream to downstream. If these two sectors are well coordinated, I think the investment cost in terms of the financing cost can be significantly reduced. That would be my very short answer. It's a very big question, so we can explore it further maybe in future studies. Thank you.
Oh, thank you
Thank you,
very
Mr.
much.
Lee.
And now I pass to Tanya.
Yes, thank you, Professor Linda, for the questions and also for the opinions of the both of the speakers. I would like to summarize both presentations as the following. First, within the ASEAN, the small-scale energy opportunities are in Indonesia and Myanmar, the LNG to generate power, in Singapore to build the LNG bunkers, in Thailand to use LNG as transportation fuel, and Indonesia to use LNG as diesel replacement in remote off-grid areas and LNG heavy plant. Second, from the projection model made by Dr. Lee, in delivering small-scale LNG to islands in the Philippines, the best scenario is to have the primary floating storage regasification unit or FSRU in Cebu and Zamboanga with no primary onshore terminals. For the distribution of LNG from primary terminals to secondary and tertiary terminals, an optimal mix of small and large LNG barges is recommended. Now we have come to the end of our webinar, the small-scale LNG role in ASEAN interconnections. Thank you for joining our one-hour webinar. We would like to address our thanks to Mr. Wiegand and Dr. Lee as the speakers, and also Professor Linda as the panelists. If you have any further questions, please send them to apac@aseanenergy.org, and we will convey your questions to the panelists. We hope you enjoyed this discussion and gain new understanding of the current environment of the small-scale LNG in ASEAN. Have a great afternoon, everyone, and hope to see you at AIBF 2018.